All right, so in this video, this is the second part of 3.2b. We're going to be moving away from our graphing calculators and now looking at how we can sketch a graph when we're given some basic information. Now, these graphs are not going to be precise. It's just a general sketch of what the graph could look like. But there are some details that we need to include. So let's look at this first example. So it says that it's going to be positive on the intervals from negative infinity to negative 4 and from negative 1 to 4. Now remember, those are intervals using the x-axis. So I'm going to use a dashed line here because before negative 4, the graph is going to be positive. So the graph is going to be up here. And then from negative 1 to 4, it's also going to be positive. So I'm going to shade up here between negative 1 and 4. So I know the graph is going to be in those regions. That's where it's going to be positive. It's going to be negative from negative 4 to negative 1, which makes sense. It'll be negative in that region, and then from 4 to infinity, it'll also be negative. So I know the graph is going to run through those regions. Now, let's go up to the top there and go through the different steps. So the first step is identify or estimate the x-intercepts. This tells me that these are where my x-intercepts are going to be, because in between those, that is where it's going to cross into the different regions. So that's where it's going to hit the x-axis. So I know those are my x-intercepts. Okay, so we just covered those two pieces, the bullet points. And now, where is it decreasing? So the decreasing intervals, those are going to help us identify step 2. Those are going to help us identify the turning points. Because it's decreased. So think about it. It's starting up here in this first yellow region, and it's going to come down. So that means it's decreasing until it gets to where x is negative 2.67. Now remember, these are x values. So when x is negative 2.67, it's about here. So somewhere here, I'm going to put a point. It doesn't matter where you put the point. Okay, it's just somewhere there, or I should say, it doesn't matter where, for what y value we put that point. But that x value would be negative 2.67. So I could put it anywhere in between there, or in that yellow region, as long as the x value is at negative 2.67. And then it's going to also decrease from 2 to infinity. So that means, so again, think about it this way. The graph is going to come down. We're going to get to more of the graph here in a second. It's going to hit that point. It's going to come up. And then it's going to increase again in this region. And then it's going to hit a point where x is 2. So let's say it hits a point there. And then after that point, it's going to decrease from 2 to infinity. So that is one of the other turning points, is when x is 2. So it doesn't matter where the y value is. I could put the point here, or I could put it down here. I could put it here. I could put a point anywhere there where x is 2. So just pick a point where x is 2. As long as it's in that region where x is 2, that's all we're looking for. And it's increasing on the interval from negative 2.67 to 2. So again, those are establishing our turning points, which we've already included. So now we're just going to graph it. So I'm just going to draw a line that's going to go through those regions, and it's going to hit those x-intercepts and have those turning points. So again, it could look something like that. You might have had a point where maybe you pick a point down here. So then the graph will look like this. Again, the turning points, we just know the x values, we don't know the y values. So there's going to be a variety of different shapes as long as we have the turning points at the correct spot. For the x value, for the y value, it doesn't matter. All right, so I know that was only one example, and it's something new. But I want you to try this for the next one. So I want you to do as much as you can. So include all of these bullet points. Start with, again, where it's positive or negative. Shade those regions. That'll help you identify where the x-intercepts are at. Then use where it's increasing and decreasing to figure out where the turning points are, and then sketch the graph. So go ahead, pause the video, and hit play when you're ready to check to see if you have a good sketch. So if you have a graph looking something like this, again, there could be slight differences as far as how high up or how low it goes, but the turning points for the x values should be the same as what I have. Now, if you're struggling with those turning points, look at what I just did here. So I didn't do this in the previous one, but this might help. I underlined all the numbers. Negative infinity just means that it's going to keep going down that way. It's not going to change directions. but it's going to change directions at negative 1.5. It's going to change direction at 0. It's going to change direction at 1.5 because those intervals are along the x-axis. So those are giving us values for x. So they're not coordinates. So we don't just use the first number listed. We look at each individual one because those are all on the x-axis. So at negative 1.50 and 1.5, you would have a turning point. And so at negative 1.5, just pick a point anywhere. I did here. At 0, pick a point anywhere on the y-axis where x would be 0. And at 1.5, pick any value for y where x is 1.5. And then you'd have your turning points, which if you notice are the same for where it's decreasing. Those same, you can do the same thing. Negative 1.50 and 1.5 are the same exact values. So those basically just establish that those are in fact are your turning points. And that would be a sketch of the graph. All right, now how do we interpret for these story problems? This is where you're going to use your calculator. So they give us this equation. What does this equation represent? In science class, Abby mixes a fixed amount of baking soda with different amounts of vinegar in a bottle, capped by a balloon. She records the amount of time it takes the gases produced by the reaction to inflate the balloon. From her data, Abby created a function to model the situation. We're going to learn later how we can create tables and do all that and create equations, but for right now, they're giving us that function. They're giving us the equation. So this is the equation that we would use. And that represents the seconds it takes to inflate the balloon. So x here represents the number of cups of vinegar. How do I know that? Right there. And the total represents the seconds it takes to inflate the balloon. So now let's look at part A. How long would it take to inflate the balloon with 5 quarter cups of vinegar? So we have 5 quarter cups. X represents a quarter cup. So I'm just going to replace X with 5. And so all you would do is literally on your calculator. So I want to make sure you type this in correctly. But on your calculator, we would type all of this in at once. Do not break it up. Let me do that bigger. There we go. We don't want to break that up into individual pieces. Your calculator knows the order of operations, so don't try to do the order of operations for your calculator. You're more likely then to make a mistake on your own rather than putting it in the hands of the calculator and have it do it without making mistakes. So make sure that you put the numbers inside of parentheses and an exponent outside the parentheses. Otherwise, if you do that correctly, you'd end up getting 6.26. So that would be seconds as your answer. Now that one's pretty straightforward. Let's look at this one. This one's a little bit more trickier. So here's the function. Let's figure out what this function represents. Danielle is engineering a new brand of shoes. For X shoes sold in thousands, that's very important, the units there. So X doesn't represent 5 shoes. If X is 5, that would represent 5,000 shoes. If X is 12, that would represent 12,000 shoes. So X represents the number of shoes sold in thousands. That function is going to give us the profit in 10,000s. Okay, so if the profit is 1, that would represent 1 times 10,000s or $10,000. So we've got to be very careful. Whatever answer we get, we got to put that in terms of 10,000s, which means we multiply it by 10,000. So we want to figure out how much will be earned in profit for selling 1,000 shoes. So think about it. 1,000 shoes, X represents the number of shoes in thousands. So in this case, X would equal 1. That's very important. So we would replace X with 1 in this function. So we'd have negative 3 times 1 to the 4th, so on. And here, technically, this would be one that would be pretty simple to do without a calculator, but otherwise we could just use your calculator. The reason why I say it'd be pretty simple is 1 to the 4th power is 1, 1 cubed is 1, so all of these would just stay 1s. So you could just take negative 3 plus 4 minus 2 plus 5 plus 10, and you get an answer of 14. Or if you do that on your calculator, you get an answer of 14. Now we got to interpret what that 14 means. That 14 represents 14 10,000. So we'd have to multiply that times 10,000. So that's equivalent to $140,000 profit. So if she sells 1,000 shoes, she would make a profit of $140,000. All right, now let's look. So we're going to need to look at the graph for this one. It says, what do the x and y intercepts of the graph mean in this context, and do those values make sense? Now let's actually start with the y-intercept, because the y-intercept we can get without looking at the graph, because remember the y-intercept is your constant. So the y-intercept would be when x is 0, y would be 10. And to interpret that, what does that really represent? That means that they would start with so remember, the y value represents the profit, and the profit is in $10,000. So 10 represents 10 times 10,000, which would be $100,000. So what that means is that there's 100,000. They're starting with $100,000. So maybe that means that's what you would have in the bank, or that's what they have if they sell 0 shoes, is $100,000, which technically would make sense because in order to start a business, you're going to need to start with some money in the bank. All right, now for finding the x-intercepts, we're going to have to look at the graph. And so when you go to graph this, you're going to have to change your window settings. If you're wondering what I changed my window settings to be able to get a graph that looks like this, you can pause the video now and adjust your window settings. But this is what the graph would look like. And when you go to find the x-intercept down here, you're going to get an answer of 1.915. And the decimal is going to keep going on. But I'm going to show you how we can use that to be able to answer the question. So let's look back at our notes. All right, so the x-intercept, again, is going to be the coordinate 1.9150. Okay, and so here's what that means. The x values, remember, represent the number of shoes sold in thousands. So we're going to take that 1.915 and multiply that times 1,000. That gives us 1,915 shoes. So after they sell 1,915 shoes, they'd have a profit of $0. So that's what that represents. And again, the question is, does these values make sense? I don't know why, if they sold 1,915 shoes, that they would end up with a profit of $0. So I would say that there's probably something wrong with this function, because I can't think of a situation why selling more shoes would result in not making any money. So, but that's how you would interpret the x-intercept and the y-intercept, at least.